Hi, and welcome to this third episode of our tutorial series where we're creating a base builder game using the SpriteKit framework. And after our last episode, our application is still pretty boring, but we do have did write tests to show that at least our model is working as intended. And today we're going to continue that kind of work because we are going to focus on implementing item requirements. So we did the position last episode and made sure that we could also move the location. This time we're going to add items as requirements for jobs, and we will create a new job type that's able to fetch items somewhere from the world. This requires a bit of work because we're going to add new data types to describe items, and we will be adding the items requirement. We'll also add a new job goal for fetching items. We need to consume items to complete a job, and we somehow need to add items into our world and into our entity. So our entity should have an inventory. And again, we'll just be writing some tests to demonstrate this working. So let's dive in. Let's open Xcode. Load our base builder tutorial, and we'll start by creating the new data types. So we'll create a new Swift file, and I'll call it item. And for now, an item will be a pretty simple structure. For now, let's just give it a name. That's all. And we will expand this in a future episode. But this is enough to get us started. Also, I'll create a data structure called an item stack. It's basically just telling how many items are at this specific location. So I'll have an item stack, and it has an item and an amount. And we'll use these item stacks to describe the amount of items that you need, or the amount of items that are available at a certain position in the world. So that's our item and our item stack. Let's look at the requirement that we need. So we now have a requirement for position. Let's add one for items. And here we'll use the item stack to describe which ones we need. So again, we'll be using associated values in the enum to also keep track of this data. Because we created a new requirement, compiling will now fail because there are some cases that we're not taking into account anymore. We'll fix that in a bit. I also quickly want to add the new job goal. Fetch items. And this one will have an item stack associated with it as well. And this again will give compiler errors because these are used elsewhere and we haven't implemented any behavior for the fetch items yet. So let's see what we need to do. So in our check requirements function in the entity, we now need to add a case for items. And we need to get our item stack back. So we have our item stack. Let's make sure that we check to see if we have enough. So let's see. First, let's add an inventory to our entity. So we'll create a new variable. And this will be a dictionary that has items in it and an amount. And this requires item to be hashable, but we can fix that easily because this can be synthesized automatically, just like we did for vector. So now we should have an inventory dictionary, and I want to create a small convenience function to see how many I have of an item in my inventory. So let's go all the way down, and I'll create a marker here. Create a private function called inventory for an item, and this will return an integer, and this will simply be our inventory and what's in the item with the default value of 0. So if the item is not in the inventory, we will get back 0, and otherwise we will get the amount back that we had. So let's see. So now we can say we have an amount in our inventory, and that is inventory for the item stack.item. And if our inventory amount is less than the item stack amount, then we eventually need to return false because we don't have enough in our inventory, but we also want to create a new fetch job. And that takes a bit of takes a bit of work because first we need to check how many we need to fetch. So I'll create a fetch stack that will be a new item stack. And we will take the item we already wanted, but the amount will be the current item stack amount minus what we already have in our inventory. So we don't need to fetch more than what is needed to get enough in our inventory. Also, the question will be, where do we get the items from? Our world currently does not yet have any items in it. So our world should have items as well. So we'll create a new variable called items, and this will be dictionary of a vector and then an item stack. So we can have one item stack at most at every position. And then we can start working with this a bit. So we'll create a new mark for items management. And what I want a function that will get me a location with items. With for a different item stack. And this will return a vector optional. We will return a location if we found the item somewhere, and we will return nil if we can't find anything. So what we'll do is we'll iterate over all the locations and the stacks in items. And if the stack.item.name equals our item stack.item.name, and the stack amount is more than 0, then we will return this location. So we will, in this simple implementation, we're returning the first location that has at least one of a specific item. We're passing in the item stack so you can make more advanced behavior where, for instance, you're prioritizing locations that have the most of a certain item or just enough of a certain item to satisfy the exact need. But for now, this will be enough. So we'll return nil if we can't find any location. Now we can go back to our entity and we can try and get a location. We'll say if let fetch location equals world get location with items for our fetch stack. If we find one, we want to create a new fetch job. But we don't have any simple way of creating a fetch job yet, so I can't just like to create movement location job. I want to create a builder function that can create a fetch items job. This will take an item stack and a target position, and this will return a job. This would be a job with the job call of fetch items, and we will fetch the item stack. And our target position will be our target position. The build time will be 1 for these ones, and these will have the position as a requirement. So we can only fetch if we're at the right location. So let's get back to our entity, and we will be using this new job creation function. Say job, create fetch items job, and we will fetch the fetch stack at the fetch location. And just like the last one, I want to debug message that we created this job. So this has our check requirements function now covered. What we also should do is say we have the required items in our inventory. I assume that the job will consume these items. Otherwise, why would you need them? Well, perhaps you have something like a tool that you require, but we'll look at that more as workstations and so on. So that's a different solution. So for now, we will assume items are consumable. What I basically want to do is in our work on job, say we meet all the requirements, we decrease the build time. But what I always also want to do is, if the build time is 0 and the job is almost complete, we should consume items and or process other requirements. Perhaps other things need some processing here as well. So what we'll do is we'll create a new function, new private function called process requirements for a job, and we'll go through all the requirements. And we will see what kind of requirement it is. If it's an items requirement, we want to somehow consume items. Create a function for that as well. Otherwise, we won't do anything. And we want to call this function in just before we complete our job. So we'll say process requirements for the current job. So let's see. So we have your process requirements here. Let's go down a bit and also create a sort of section for requirement processors. There will only be one for now, but maybe more need to be added later on. So we'll create a private function called consume items, and this will consume an item stack. We'll have an existing amount equals inventory for item stack with item. We will assert here that the existing amount is more at least the item stack dot amount. An assertion is something that will be checked through one time, but only if you're running in debug or mode, such as in the developer. So if this should always be true because we already checked all the requirements. But if it's not, then in debug mode this will fail. But if you run it outside of that, then this will just be ignored. But this should never fail because we already checked the requirements before we're calling the process requirements. Okay, so let's continue. So we have our consume items. We've asserted that we have enough. Then our new inventory for the item stack item will be the existing amount minus the item stack amount, basically the amount that we're consuming. And now we can go here and we can say consume items item stack. And that's our process requirements done. Let's try and build, and we still see we still also need to complete this the new fetch items job. So we'll add a new case, fetch items, and this will have an item stack with it. And basically we want to again have some form of fetch items function. So we'll implement it, but first we will pop the from the stack the job that we're about to finish, and then we need to have some form of a function that can actually take the items out of the world. So we'll also add a marker for job completion handlers. We'll have a private function called fetch. And we will fetch from the world. We will have an amount that we still need to fetch, because perhaps we can't get enough immediately. If the available stack, let's get the item stack at the position that we need. Let's see, the items to transfer are either what is needed in the item stack or what is available. So either we take what we can get from this position in the world, or we take what is needed to fulfill the fetch job. Then the remaining amount will be the item stack dot amount minus the items to transfer. And if the items to transfer then is equal already to the item stack amount, then the remaining amount will be 0. Our inventory for this item will be our inventory amount. Did we already pick that up somewhere? Let's get that as well. Is the inventory for item. Is our inventory amount plus our items to transfer. And our world, the amount of items in the world, will be the available stack minus amount minus the items to transfer. So basically we're adding to our inventory and we're taking away from the world. Let's see. did we make in item stack? We made this immutable. Well, let's make that mutable so we can at least change item stacks. So this should now work. And now, what do we need the remaining amount for? Well, if the remaining amount is more than 0, so we don't have enough yet, we weren't able to get enough in one go, so we'll create a new fetch job. So let's see the remaining items. Fetch stack is an item stack. Of the item we need, and the amount is we need is the remaining amount. Then, if we can find this somewhere in the world, because we again need to check whether this is somewhere available in the world, then we'll create a new job on the stack for this remaining items of fetch stack at the fetch position. So this is a lot of, it's a pretty complex function, but most of it is arithmetics to somehow increase and decrease the inventory and world amounts and looking how much to transfer. So I think this should now at least compile, and this should do what we expect it to do. But first, let's write some tests to validate this. So what's the first test that we will write? Let's see if we can actually consume items. So let's go to our entity tests, and we will create a new test. Test meeting requirements consumes items. So let's get a world. Let's get a required item. And let's get an entity. And this will be at a position, and we'll also have a job. This can be a change tile job. It'll have the target position. It'll have a build time of 1, but most importantly, it will have an items requirement. And what it will require is the required item, and it will require 1. We will put this job on the stack. Let's see. So our entity has an inventory, and for now we will give it the required item and 10 of it. So we can now assert that the entity inventory for the required item is 10. We can update the entity in the world, and now it should have, instead of 10, it should have 9. Okay, let's see if this test does what we expect it to do. Okay, so the test succeeded. Then let's test if missing items spawns a new fetch job. So we'll say have a function test missing item requirement spawns fetch job test. So we'll have world again have a world. We'll have an item. Go to one. We'll have this item somewhere in the world. And there'll be 20 of it. I have an entity. At position 0. I will have a job. And our job goal will be to change the tile to, for instance, floor at position 0. Then this will have a requirement of items, and we require the item, and we require 10 of these. We will put this job on the entity's job stack and start asserting stuff. So let's first assume that our entity at least has one job. It should be exactly one job. Now let's update our entity in the world. Note that we haven't set the inventory for the entity, so it shouldn't have any of the required items just yet. So now we should have 2 jobs, because it should have spawned a second job, and specifically it should have spawned a fetch job. So let's see. So we should have a top job on top of the stack. No, we should actually have a first job. We should have entity jobs on top. That's the one on top. And we should have a second job. Else, we will fill the test. These should not be. Will return. So let's see. With our first job and job goal should be fetch items job. Otherwise, this is something else. That's not what we expect. So we fail the test. It should be a fetch job. And we can do something similar for the second job. But this one should be a change tile job, because that's the first one we scheduled. Let's see if this test also passes. Okay, so this one passes. And because the fetch job is somewhat complex, I want to also be able to test specific jobs. So we'll create a new unit test case class called job test. Let's see, we have a func. And we'll test the fetch job. And this will have a world have an item to fetch. I will have an entity. We need to import again to get access to stuff like entity and world. There'll be an example entity at position 0. Then we'll have a job. And this will be a create fetch items jobs. And what we want to get is our item to fetch. And we want 1. And we will get them from a location to the right. We'll put the job on the stack. And our world to the right will indeed have the right amount of items. Well, at least enough. So let's say there are 5 here. We will assert that the entity in its inventory for this item has 0. And then we will update a couple of times. So we'll update it in the world, and the first update will fails. But we'll create a move move to location job. Then we will have an entity update in the world that will succeed in performs a move to location job. And we have an entity update that finally succeeds, performs the fetch items job. Now let's see if this did what we expected it to do. So we assert that our entity's inventory for the item to fetch is now larger than 0 or greater than or equal, that we have at least 1. Then we can assert that in the world this is our item to fetch. We can insert that in the world we need to give this default value should be less than 5. So there should now be less after fetching. And we're not specifically saying how many, because the logic of how many an entity takes might differ. It might take exactly what they need. It might take a sort of standard amount, like a standard stack amount. They might make different choices. What we want to test here is that we get stuff from the world into inventory. So let's quickly run this test. Let's see. So this test is not yet succeeding. So let's see what is happening. Again, we can use the console and we will filter. And let's see. On the subsystem, it will start, and then we can perform this test again. And let's see what's happening here. So it works on the fetch items job. It create a job, move to location, did not meet requirements. Then it's working on the move to location, it finishes move to location. Then it works on fetch items and it finishes the job fetch items. So the job gets completed, but somehow we are not seeing the result just yet. So let's look into a bit more detail. So let's do some debugging. So let's go and find our entity and let's see what happens when we complete. Oh, we forgot to call the fetch completion handle that we just created. Well, if it was this simple, that'd be amazing. Okay, cool. So, and I will leave this bit of debugging in because debugging is such a big part of development. And it's important to show how that works as well. So let's see. What I also want to do is I want to test if you can't get everything that we get a fetch job for the remainders. So let's see. An incomplete fetch creates a new fetch job. Again, we need a world. Again, we need an item to fetch. We need an entity. Somewhere in the world. Then we need a job. We need a create fetch items job, and we need a new item stack with the item to fetch. And we need, let's say we need 10. We get them from the right. However, there won't be enough there to fulfill the job completely. So let's schedule this job and let's make sure that in our world items.write has our item fetch, but it only has 5. And we requested 10, but we'll make sure that our world also has some on the left. And these there's also be an item to fetch. It will also be 5. And let's see. So let's make sure that our target position for the job, top job, is indeed to the right. So we will be taking from the right job stack. We need to do some updates, so we will update in the world. The first one will fails, but it creates is this what I want to test? No, this is not what I want to test. What I want to test is, let's see, let's make sure our entity is also in the correct position. Then we can do world, we can do entity dot update in the world. This should fetch 5. So what we can do is we can assert that our entity is inventory for the item to fetch is indeed 0, but after entity inventory for items to item to fetch should now be at least larger than 0. Also, we should now have a top job that has a different target position, because it should now be looking at finding these from the left. So what we'll do is we will make sure we have a top job. And then we will make sure that our top job target position equals to the left. So now it should be looking, it should have taken from the right, and now it should try and take, or should at least have a job to take from the left. So this one is successful as well. And see if all the other tests still run as well. Right, so these are all successful, so that's nice. So this should be enough for now. Next time we will start visualizing the world. So this has been a long episode. There's a lot of stuff to implement. I'm sorry if it was a bit confusing here and there. If you have any question, please leave them in the comments below, and I'll try and get back to them in the next episode. But on the other hand, being able to have requirements for jobs that consume items is such a major part of these types of games, because basically what we created is a sort of crafting system. We're able to complete jobs. This time, for instance, jobs that change tiles. But this could also be a job to create a new item that consumes other items. So basically, this is the first half of a crafting system, and that's really powerful, I think. So thank you very much, and have a good day.